Hi, everyone, and welcome to the first webinar in our virtual classroom series. In this series, you'll learn everything you need to know about upgrading and migrating to Oracle Database 19c. And we have 6 exciting webinars in this series.
Future topics include upgrade and auto-upgrade in particular, migration to multi-tenant and the cloud, including all the little bits and pieces, and not to forget performance stability, so you can safely upgrade without having to worry about performance. And that include all the tips and tricks and all the secrets.
Our today's topic is release strategy and patching best practices. So we would like to introduce you to make the right choice, which release you need to upgrade to, and how to find the most important patches you need to apply. But not only how to apply them, but also a lot of best practices, and we would like to show you demos as well. Before we start, a few organizational things up front. At first, the slides. You can access the slides already. The slides are on the upgrade blog, mikedietrich.com/slides. And if you like to, you can download them right away and look into the slides while we present. Second, the seminar will be recorded. So no worries if you have to leave earlier, or if you want to share the seminar later on with colleagues, with your team, with your mates, no worries here. It takes usually 1 week until the recording is available for on-demand view. We'll make it available via link on the upgrade blog as well, mikedietrich.com/videos. And you will get an email under the email address you registered for the seminar with the link to the recording afterwards as well. For questions during the seminar, that is very important, please use the Q&A. Don't use the chat, use the Q&A, and Roy, Daniel, and myself, we will try to answer all your questions. In case we can't answer them, feel free to drop us an email afterwards. Our email addresses at Oracle usually work, firstname.lastname@oracle.com. And for today, we have also a nice agenda. We will start talking about your recommendations, also for the release strategy. Then we will give you patching recommendations. We will explain the patching process and give you clear recommendations, what we want you to apply and what is maybe not the best thing to apply. Then we really dig deep into the patching topic with Welcome to the Jungle. And we would like to highlight a lot of important things, give you also clear recommendations, show you best practices. We will show you demos. Approximately 1 hour into the seminar, we'll do a 5-minute break. Then feel free to refresh yourself, get something to drink, refill your cup, your coffee, your tea, whatever. And after 5 minutes break, we'll go on and cover more around that patching topic. The entire seminar will span approximately 1 hour, 45 minutes. Enjoy, and let me start introducing Roy. So Roy is our Vice President for Database Upgrades, for Utilities, which includes Data Pump, SQL Loader, and for Patching, which covers Data Patch. I worked for Roy for a very long time, and we both cover customer projects all over the world. So working with Roy is great fun, and traveling with Roy is even more fun. So Roy is based on the East Coast of the United States, and he is with Oracle, I don't know, more than 25, 30 years? Oh, very long time, actually. You can follow Roy on Twitter. You find his Twitter handle here on the slide. And now it's Roy's turn.
You'll also hear from Daniel, who's our lead product manager for cloud migrations. Now, Daniel has a deep background as a DBA, so he brings a lot more than cloud migrations to the table. You can follow him on Twitter, but more important might be to access his blog, dohdatabase.com, which gives you really deep dive information while still living up to its title that databases are fun.
This is Mike Dietrich, Distinguished Product Manager. Do we really need further introduction? I mean, he is, after all, a true Oracle superstar. He has been with Oracle for ages, and he is the product manager for upgrade and migration. So he's really the go-to guy on those subjects. His blog on mikedietrichsde.com is really a must-have on your blog roll, and you should put it on top of your list. It contains so much valuable information and so many good tips and tricks.
So before we really start, we would like to show you some examples of things you definitely shouldn't do. So let me start here with an email. And this is an email, as you can see, it's like 2 years old here. A colleague asking for a customer, LAD, this is Latin American customer here, to migrate 70 databases. So I would say it's a small to mid-sized project. But the interesting part, it's Oracle 7. And it supports an important application. It works with Oracle Forms. So this is an old version of Forms. And it's across many countries. And the customer wants to modernize the application now to a 3-layer architecture and move all data to an Oracle Database Central repository. So typically our sales team would come in and say, cloud, this is a cloud thing. But what we want to explain you here is what you definitely shouldn't do. Oracle 7 in 2019. So I started at Oracle in 1996. And this was the time when we just shifted from 7.2.3 to 7.3.2.1. And this year, in that case, we did a follow-up, was a 7.3.4 database. So this was early 1997 released. So you can do the math, 1997 to 2019, that's 22 years. You, for many reasons, you shouldn't stay on such old things. But even worse here, if an application is sitting on that application will never run against a modern database. So you need to change a lot of things. It's not just a database upgrade or a database migration. I mean, we can still take export import and export its database. We could even go to 19c into a CDB if we want to. It works. We can do that. But this is not the point. The point is really we need to make sure performance is good and the customer has a huge, complicated project. So don't wait too long. The longer you wait, the more complex it will become, the more costly it will be for you, and the more risky. And that is what we really want to avoid. We want to mitigate risks. We want to make projects really not too complicated, ease your life. So don't wait too long. The next one here, another email, just came a month later from another colleague here. So you see from oracle.com. And here the customer is running a SaaS application, so software as a service, on 10.2.03 Enterprise Edition. Now they have decided to go to 18c, so most likely this is on a Linux system which doesn't support 19c yet, or 19c at this point wasn't out on-prem yet. The customer wants to have near zero downtime. So of course, we would come in and say, hey, Golden Gate is the solution. But this is not what I wanted to show you here. I want to show you here that we have production, we have physical standby, everything on 10.2.03 Red Hat 5. So this is completely outdated, no security fixes for ages. And just that you'll be aware, the general availability of 10.2.03, that patch set, was on 29th of November 2006. That was before Steve Jobs introduced the iPhone. So just to put this in the right relation, because we all have smartphones these days, or most of us, Steve Jobs went on Moscone Center on stage in October 2007, a year later. So this is how old this database is. And now grab out your cell phone and tell me that your cell phone is like 15 years old. Certainly it isn't. So your database shouldn't be that old either.
With the focus of this webinar being our release strategy and patching practices, it makes sense to first start by talking about why you're upgrading in the first place, which, if I have to guess, is probably about our lifetime support policies. What you see here is a depiction in a chart form of our current available database releases. And you may be on 11.2 or 12.1 or 12.2 right now, and each of those releases has a different amount of time left in its official support period, which means the time during which you get support such as bug fixes, security patch bundles, and so on. And most customers wisely don't want to operate their database when they can't get access to fixes for known security vulnerabilities, for example. Now, there's a difference between each of these databases in terms of where we are in the life cycle. The older ones, such as 11.2 and 12.1, are in a period where, in order to get those patches, you need to be paying for support, either market-driven support from Oracle ACS, which stands for Advanced Customer Services, or for 12.102, extended support. Now, if you have a ULA, which is an unlimited license agreement with Oracle, you can get extended support as a zero-cost item as part of that ULA. But if you don't, if you're paying on CPU-based licensing, for example, then you would have to pay extra for that extended support. Now, we accumulated quite a customer base on 12.201, which was kind of unexpected, being that it was the first version in our 12.2 release family. And because we have such a high customer base on it, we did add a couple of years of limited error correction support onto its initial 3-year support period. But even there, you're in the waning days of that support period, and you really need to be thinking about migrating to a release that will have support into your past mid-2022. And even more urgent is the need for people who are on 18C to get upgraded to 19. 18C is a shorter-term innovation release, and that means that it's not going to get any extended support whatsoever. There was never any confusion about that in terms of our support documents or differences between our policies and our support notes. So there's no excuses there. It's time to move to 19 for sure. So you see 19 has that 5 years of Premier support, of which there are more than 3 years left right now. And then it will get 3 years of extended support, which again, if you have a ULA, that extended support can be a zero-cost item. And then there's 21, which is available right now in our cloud. We followed that cloud-first release strategy for 21, just as we did for 19 and 18. And it's available in our database cloud service and in our autonomous always free tier right now. So I've talked about different types of releases here, and you've seen that some releases get much more support than others. And we have terminology for that we're trying to settle on and kind of make across the board universal terminology. A long-term support release like 19, that's the one we intend you to deploy your mission-critical production systems on in most cases. And that's because it will be a platform that will be there for at least 5 years of Premier support and 3 years of extended support. Most people don't want to upgrade those critical systems every 2 or even 3 years. They want to be able to sit somewhere comfortable and maybe not have to upgrade until the next time they recycle their hardware, which is usually on about a 5-year span. Now, we also produce releases like 18C, 21C, and we call those innovation releases. Those are meant for customers who want earlier access to new features. Those new features, of course, will be in the later long-term release, but if you want it as early as possible, say you want, for example, the binary JSON data type that's in 21. If you want to start developing on that now because your application can take advantage of that, and you're planning on certifying and even say on 23 when that comes out as a long-term release in a few years, you might want to get that innovation release into your development environment, start using it. Even maybe some early adopter customers might want to deploy it in production, but you do have to be aware that you will have to upgrade that release probably within 2 years of when you first start using it. So that's your difference between long-term support and innovation releases. If you want any more details on this, such as there are details such as the fact that innovation releases don't get release update revisions. I'll talk about that when we get to patching later. Go to MOS Note 742.060.1, our release schedule of current database releases, which is kind of our roadmap note. It gives you everything you need to know. It's our single source of truth in our support documents about our release current status and strategy. Now, I mentioned 12.2 and being the base release for the 12.2 family, and this did cause some confusion when we changed our release numbering from the old major dot minor kind of motif, 11.1, 11.2, 12.1, 12.2, and then we went to 18 immediately, and that kind of threw people for a loop, and probably we didn't communicate that as well as we could have, but it's important for you to know, and we've been repeating this now for about 3 to 4 years, 18C was only about 45 days away from being released as 12.202 when we changed the number. It was really just a number change on the 12.202 patch set. And 19 was already under development as 12.203 when we changed our numbering scheme. So 19C can really be viewed as being the terminal patch set of a 12.2 family, and 21C, that innovation release, is kind of that first release of the next family. And that's why we give you that longer support on 19C, because it incorporates all of the improvements that were put into 12.2, all of those new features, but it's also got a lot of stability fixes in there. And that's what we expect you to be on for the next 5 to 7 years. The other thing that I'll mention is, while we don't have our next long-term release on this chart, we will be talking about that soon. And our goal, what we always commit to, is that we will make sure that you have enough time to upgrade from one long-term release to the next. That's what we always want to make possible for you. Now, that MOS note 742060.1, that's the type of thing that a lot of DBAs would access, DBA managers, but often your executives, they want something in an official policy document. And we do have our lifetime support brochure PDF file that's linked off of oracle.com. You can download that and you'll find that it agrees wholeheartedly with the MOS note. So whichever way you want to consume that information, whether your leadership needs to know, well, why are you recommending that we go to 19? Well, here's why: because the support dates mean that we can go to 19 now and beyond that for a good 5 years before we have to do our next upgrade project. So now that we've talked about that, let's just go a little bit more into the release numbering and how the significance of the digits in the release number have changed.
Thanks, Roy. Let's look a little into the new number format. So back in the good old days, you would talk about 11.204, 10.205, or 12.102. So even though we had a 5-digit number format, we always referred to them with 4 digits, because the 5th digit was always 0. But the same actually applied to the 3rd digit. So with the release of Oracle Database 18c, we changed to a new, smaller number format. Now it's only 3 digits: year.update.revision. So you can immediately identify on which specific release update or release update revision any given database is running on. This is so much easier, and you can also get information about which year that specific version was released. So when someone talks to me and say, "Hey, Daniel, I got a problem with my 19.10.0 database," I immediately know which release update it runs on and if there are any revisions installed on top of that. So it's much easier for me to set up a reproducible scenario. But let's look a little deeper into the new number format. Let's try to log into SQL+ and look at the information we get. Well, the first thing I see is 19.0 and 19.9, and there's 5 digits. And also, if I query $, instance, the version column still says 19.0000, whereas there's a new column called version full, which tells me 19.9, which is more correct, but it also has a lot of zeros. So, Daniel, if you told me there's a new 3-digit number format, why are there 5 digits all around the database? Well, the answer to that is that this change came in fairly late, or actually just before we released Oracle Database 18c, and we were already well underway with the development of Database 19c. So in order not to introduce too many side effects and to preserve backwards compatibility, the database still has a 5-number digit internally, but please rest assured it's only the first 3 digits that are significant. It's also good to be able to distinguish between a patch and an upgrade. So, is it a patch or is it an upgrade? Well, you can easily tell that by just looking at the number format. If it is a patch, you'll see that the second number changes from, in this case, 19.3 to 19.10. Had it been a release update revision, it would have been the 3rd digit that changed. Now, in contrast to that, if you look at a database upgrade, if you go from database 18 to 19, you'll see that it is the 1st digit that changes, in this case, from 18.6 to 19.10. So just by looking at the number format or the number change, you can see whether it's a patch or an upgrade. And you can also see that by looking at the tools that you use for either a patch or an upgrade. If you use OPatch, it's a patch, whereas if you use preferably Auto Upgrade or DB Upgrade, it's an upgrade. So we covered the basics. Now let's head a little deeper into the details on patching.
Now that we understand the significance of the version numbering and how that has changed along with the high-level release numbering, let's talk about patching both on your current Oracle database, the version you're upgrading from, and the 19c, the version you're going to be upgrading to. Now, if you're coming from 11.204, 12.102, you're going to be used to terms like PSUs. PSU means patch set update, and what that is your quarterly bundle of security patches and regression fixes that gets issued in January, April, July, and October of every year. Now, what's in a PSU is, as I mentioned, security fixes. So, of course, we are on top of security vulnerabilities, whether they're identified by our internal teams or by external security researchers or universities, what have you. And we issue those security bundles every quarter. And we used to issue bundles of just security fixes, what were called CPUs or now called SPUs for 11.204. But then it came out, basically, customer experience was that in addition to those security fixes, they needed certain critical fixes for really high priority bugs, instance crashes, cluster-wide hangs, other things that might be regressions in their database environment. So we produced the PSUs for 11.204, and then that became the basic bundle for 12.102. So your PSU has security fixes and then fixes for your most important database issues such as crashes and hangs. Now, on top of that, we found that many customers, of course, also have to manage too many overlay or what you might call a one-off fix. You might have a certain set of 14 fixes that are needed for your application database, or someone else might have 43 or 200 one-off fixes. And then every quarter when you would get a PSU, you might have to get a new version of many of those fixes, or maybe some of them are incorporated in the PSU and you get a different merge patch on top of that. And that kind of complicated and delayed the whole quarterly patching process. So what we've done for 12.102 and since is have these bundle patches. And a bundle patch includes the quarterly PSU, but then it has the most high value functional fixes, whether they're optimizer fixes or fixes to other types of functionality that are all tested as a bundle, installed as a bundle each quarter. And the intent of the bundle patch is to reduce the number of one-off fixes that you have to manage or request for your environment. It's been pretty successful at doing that. Now, it's important to note when we talk about optimizer fixes, that always raises a red flag because optimizer fixes can be very finicky. What fixes something on one database or for one application may cause issues on another database or another application, depending on how they've got hints implemented, optimizer parameters implemented, and so on. So when we deliver optimizer fixes as a part of our quarterly patch bundles, they're delivered disabled by default. And then you, as a DBA, can enable those fixes on one database at a time if you want by using a fix control parameter in your init.aura. This is good because, first of all, it means you don't have to download and install a separate fix in order to get that optimizer fix. But it also means that you don't have to have all of the same databases that might use a common Oracle home using the same optimizer fixes. If a particular application hasn't encountered an issue, you don't have to turn on a fix for it and risk perturbing your query plans. So that was all implemented back in 12.102. Now let's talk about what you're going to see when you go to 19. And that's terminology such as release updates and release update revisions. The release update is the fundamental patch bundle that we release each quarter for 12.2, 18, 19, and beyond. And if you look at the contents of that release bundle, it's security fixes, regression fixes, optimizer fixes delivered disabled by default, and then functional fixes for the most commonly encountered or highest value customer filed bugs. That is what we used to call the database bundle patch. So that has become our unit of delivering our quarterly patch bundle because it's been so successful at minimizing the number of one-off fixes needed by most customers. Now, there may be cases where you need more fixes than are in that bundle. Many cases when we have one-off fixes on top of bundles, we will roll them into later bundles because each release update is cumulative, and each update will have everything that was in the previous update plus new content in one or maybe all of those areas. And as I sit here today, the latest release update is 19.10, which included over 1,000 database fixes on top of 19.9. So it's a very comprehensive release update. Now, we recognize that not every customer wants to take on a full set of optimizer functional fixes and so on every quarter, but you do need those security updates. So we also deliver each quarter a release update revision. Now, this can be a little confusing to those who haven't been exposed to it. So let me explain what I'm talking about here. So when we have a release update, 3 months later, so say you take on the January release update, in April, we will issue a revision for that update. And that revision will have new content in only 2 of the 4 areas, which are security fixes. So they will be current on your security patches for the quarter. And then regressions. In other words, if that release update had any functional regressions in it that we were able to find and fix in the first 3 months, then they will be fixed in that release update revision. So if we are on release update revision in January, we'll see, or in release update in January, you'll see a revision in April, but there will also be a new release update in April. And that will continue on with subsequent release updates each quarter. So let's look at this in a slightly expanded example and look at how this plays out over time in your environment.
Now let us explain with a timeline example the release updates, the release update revisions, and the yearly releases. And for that example, I will use 19c here. So we start our time journey in April 2019. This was when 19.3.0, the on-prem release of 19c, became available. And 3 months later, when the next quarterly patches happen always in the January, April, July, and October, always at the Tuesday closest to the middle of the month. So typically it's a date around between 15 and 20 in January, April, July, and October. So in July here, we released 19.4.0. So the first release update, and the first release update usually doesn't contain so many fixes. At the same time, we released also the first revision for 19.3.0, so containing only new security and new regression fixes. And then in October, 3 months later, the second release update, the first revision for the July release update. So 19.4.1 is the first revision for 19.4.0, and the second and final revision for 19.3. So there's never a third revision coming. So there won't be a 19.3.3 in January. That is really important to mention, to explain, and I'll come back to this later on. In January then, 19.6, 19.5.1, 19.4.2, and in April, 19.7.0, 19.6.1, 19.5.2. If we make this now a bigger picture and go more into the future, don't be shocked. It looks like that. So there are a lot of colors here on that slide and a lot of patches. And I bet you agree here. Which patch should you apply? I'll give you a clear recommendation in a second. But first of all, be aware that patching for 18c strictly ends with the April bundle patches. So April 2021, that's not far away, actually, from now on. And there won't be any bundle patches. As far as I'm aware, the patching generally for 18, the premier support, will end of June this year. So also not very far away. And if you are on 18c, it's time to move to 19c for sure. And there won't be any extension, and there won't be any extended support for 18c. So in end of June, game over, and the last patch bundles will be released in April this year. Now for 19, of course, when we go to the very, very right side of the slide, that goes further down the road until 2024, and then further for customers who have extended support for 19C until 2027. So I didn't try to fit that on the slide. 21C coming potentially soon. And for 21C, as it is an innovation release, as we explained before, innovation releases have no revisions. So you will get only release updates for 21C. But still the question remains, what should you do? But before we answer that question, an explanation what you could do, because that is different from the bundle patches and the PSUs we had before. Because now you can, you could jump before as well. No? You could start with the July bundle patch and then go to the July bundle patch a year later. So that's possible. When we start here our travel at 19.3.0, the base release, and we go live with 19.7. Let's assume that was our starting point. So 19.7 in April 2020. Then a while later you decided, oh, I'm interested only in a revision. So you went to 19.7.2. That is possible. Then you went to another revision, 19.8.2 in January 2021. And then you go back to the release update track to 19.11. That's also possible. So very different from the old patterns where it was really hard to go from a PSU to a bundle patch or the other way back. It only worked with a complete deinstall. This is much easier handled here. So you see, you can jump, you can go from release updates to revisions and back. You could even go, if you go to July 2022, in between one period, you could change from one to another. That's also possible. So there are no restrictions. The only thing you shouldn't do, even though it's technically possible with a new home, you shouldn't go to the left on that slide. Because if you go left, that means you miss security content. So let's see, I go in July 2022, I go back to the January one of the same year. That would mean I will miss all the security patches I had already in my environment from July and April. And we don't recommend that. And I think our notes say, oh, it's not possible. It is possible technically, but don't do that. It makes no sense. And this just caused trouble. Now, still, the question remains, what should you do? And this is what you should do. Stay with release updates. There are many, many reasons why you should do that. One of the reasons is, first of all, it makes your life easier. As you saw, there are so many patches. There's such a huge variety. I would strongly recommend you stay with release updates. Unless Oracle support tells you, no, you take the revision. We had such a case in Exadata very early 19.3. But otherwise, I don't see many reasons to go with revisions. Even though we recently had an interesting discussion on Twitter about that with some DBAs. Say, no, we stay with revisions, more stability. And this is the official label to brand revisions, giving you a stability release. And in theory, this looks great. But in practical environments, we will explain why you should stay with release updates. I'll give you an example. I call it the RUR trap or pitfall. And this trap or pitfall means when you look at the upper picture, you decided you go on the stability track to revisions, and then you go 19.8 to 19.9.2 and so forth. When you look at the fine print with the yellow revision, you secretly consume also the October release update 19.9.0, and you consume the January revision 19.9.1. So even though it looks like, oh, I'm on revisions, and being on revisions means I get only the new security content, that's not true. After 6 months, you get much more. But you get a 6-month-old patch then, because when you apply 19.9.2 in April, and you consume 19.9.0 from October, that is 6 months old already. Now, you could still argue with me and say, yeah, but it's just, I mean, what was potentially a regression in 19.9.0 has been fixed by then. And I agree, that could be the case. But still, you miss all the stuff we applied in January and April of the RUs, which may be over 1,000 fixes. And believe me, there's nothing worse than opening a service request. And I, as the support engineer, and I did this job 6 years, so I can tell you this from personal experience, have to tell you that, dear customer, sorry that you hit that issue, but that was fixed 5 months ago. And if you would be on the newest release update, it would be not an issue in your environment. And I had this situation now several times, especially with customers who went on the revision track for that argument of saying, oh, we are on the stability track. And in addition, what was really hard, and we need a one-off on top of revision, which took even a bit longer, which is not the intention, but in fact it happened. So I saw one customer going then to release updates, and everything was fine at this point. So I think this is a frustrating situation. I show you this with fictional numbers to make it more clear. So let's do a quick experiment, and let's assume every release update, every RU would contain 100 new fixes. And 25 of these 100 new fixes are security content. Let's limit it and restrict it only to security content. That would mean in the first picture, with every RU, I get 100, 200, 300, 400, 500. So every time 100 more fixes. Whereas in the release update revision track, I get only the 25 security fixes. So if I do this jump now from January to April on the revision track, that means I consume also now October and the January RUR. So I jump from 150 to 250. But these extra 100 fixes I get here are several months old. And at the same time in April, when you go now to the upper picture, I would have 400 fixes in my environment, whereas I stay only with 250. So the chances are high that I hit something and support tells me, oops, sorry for that, but this was fixed already. So this is why we strongly recommend that you stay with release updates and use the revisions only if there's a deep reason and Oracle support or a MAA document tells you you should go on that revision. But in all our cases, you stay with updates, please. And when you do a project, this is a patch. Don't do one of the, I think it's one of the biggest flaws I see in projects since more than 20 years. If somebody starts an upgrade or migration project, especially when it goes into a bigger scope of hundreds of thousands of databases, and then some genius does a freeze and says, we make a freeze in April, and we use the January RU, or we use the January bundle patch. And then you upgrade actually in October or in December the same year. But you are frozen on the January one. So you use 1-year-old content of patches and you're not open to new patch bundles. Don't do that. Apply new patches before you go live. It makes your life much easier. Maybe do a quick test, run some regression tests, but don't use when you go live like month-old patches. And I see this all over the place still. I know it's hard. But it's even harder if you go live and then you end up with 6 or 8 one-off patches because you hit issues which had been fixed already. Finally, a few important MyOracle support notes we include in these slides. And one of them, and a question which is coming up very, very often actually, is how should we test? What does Oracle recommend? And we have glued these testing recommendations in this overview of database patching methods. And you'll find a note for 12.2.1 and greater, which covers also the release updates, and another one for the previous ones. The thing is here that slide or this graphic, the testing recommendation by patch type, an interim patch, a one-off patch, You apply it, you do very basic testing, and if relevant, and ideally, I mean, you apply this because you hit an issue, typically like a wrong result issue, and you apply that one-off, and you quickly test your query if the result is not correct. That's fine, and that's it. For an update or a revision, you, of course, install and you try a rollback. You can do this on a standby. All of them are standby first applicable. You do some basic admin stuff. Does the database start up? Does it shut down? And you run a little bit of core and non-core application tests, which is not precisely named in this note, what core and non-core application tests exactly mean. I still test in my environments a little bit. If you have real application testing, we come to this in a third seminar. We invite you to participate there as well. Then we show you how you can easily do such verifications and make sure you don't hit unexpected surprises. And this is the list of MOS nodes we would like to highlight here. So again, as we explained before already, the single source of truth, one of the most important Oracle support nodes, 742.060.1. And you find a list of general information about release updates, about the accessibility of patches, and finally, on the bottom of the node, the download reference, the assistant, and we come to the assistant later on as well and show you also a quick demo. I think the first and the last one here, those are top in my bookmarks for MOS and my favorites because I use them all the time. And then we go to the next chapter. Welcome to the jungle.
With all this new terminology and the changes to the version numbering and so on of patches, it may be very confusing. It may feel like you're kind of getting into a jungle there, being plopped in the middle and being asked to find your way out without a map. So what we'd like to do is give you a nice guidebook for the best ways to be successful in patching and really understand where you're going and how to get there. So what we'll lay out is the basics of patching, kind of why you want to do it and what patching entails, how you go about patching the database, and then give you some tips for patching success, the best practice that you should follow so that patching becomes a non-event in your environment. I mentioned that there's a lot of terminology about there. We talk about different types of patches, one-off patches, overlay patches, merge patches, patch bundles, security patches, and so on. And it can be very daunting. So you may be tempted to just throw your hands up and say, look, I don't want to deal with this. But the fact is you need to deal with it. And the reason for that is something that I shouldn't have to say anymore, but it bears repeating: security. Software is built by humans. Conditions change. There are reasons that security vulnerabilities continue to be identified in essentially every type of software that's out there. And this happens in applications, middle tier, databases, operating systems, you name it. Software is vulnerable to exploits. So the best way to protect yourself from those exploits is to patch for known vulnerabilities. When we look at some of the more famous hacking activity that's occurred over the last decade, of course, Equifax comes to mind, right? A lot of people were affected by this. We see here over 143 million people in the US. That's almost half of all the residents, let alone the adults in the US, were affected by the Equifax hack. And the root cause of that was an Apache struts bug. Okay, so you're talking open source software there, but that bug had been fixed before the hack occurred. It's just that they hadn't gotten around to applying the fix for that vulnerability. So what will happen is any of these vulnerabilities that are found by, whether it's a security researcher, consultant, university, whatever, once the fix is available, they will document the fact, they will publish the fact that they found it because it's either good for their business or they want people to know that this vulnerability was there and why it needs to be fixed. And once that vulnerability is out there in the public domain, the knowledge is there, people can exploit it unless you patch for it. And it's not just about, say, the reputation hit that you get. In this case, Equifax took a huge reputation hit because so many people were affected by it, but it also hit them in the pocketbook. That's a pretty big settlement by any measure. No one wants to be subject to that kind of cost. And even if it's not a settlement, internal costs and other follow-on activity, whether it's having to go through and assess all your systems and make sure you don't have other vulnerabilities, whether it's losing intellectual property that you could have made money off of but now is out there on torrents somewhere. There are real costs to these security breaches. So that's what happens if you're not upgrading and staying on supported versions, and it also is what happens if you get too far behind on your patches. Now you might say, don't worry about me. I'm in good shape here because my database is not facing the internet. I know that that's a very common refrain because we've heard that from multiple customers in multiple countries over the years. But as you'll hear, that's not always the case.
No, unfortunately, you're right, Roy. And did you actually know that study shows that 92% of malware is actually delivered via email? So even though your database host is not exposed to the internet, I bet your workstation is. And if that gets infected with malware, now all of a sudden, there is a way into your precious data. So there is no excuse. You must patch your database. And having said that, let's have a little insight into the patching process. So imagine you sit at your workstation and use the database. You encounter an error. What do? First, you gather as much diagnostic information as possible. You get the alert log, you get output from OPatch LS inventory, and you try to build a reproducible test case. You upload all that together with an elaborate description of the error to my Oracle support. An engineer will then verify it and, if necessary, create a bug. That bug gets assigned to a developer. He will then first fix the problem in our main code line, so we ensure that no further versions of the Oracle database will have this specific bug. Once that has happened, you'll be able to see something like this on my Oracle support. This is a bug that I just took off the list of bugs that are included in the 19.10 release update. And you might see something like this, fixed in product version 23.1. So now what? Do I have to wait until 23 is released and then upgrade, or what? No, not necessarily. This is the first step in our patching process. When that has happened, when we have fixed the problem in our main code line, we can then create what is called a backport. And that is our way of getting that bug fix into an already released version. After that, we'll evaluate whether we can put this bug fix into a release update. Now you might ask, why don't you just put all the bug fixes into the release updates? That'll make the released versions more stable. Well, that's actually not the case, because the more bug fixes we put into a release update, the greater the risk it is that we introduce a regression, that there is a side effect from the bug fix. And we don't want that. We want the release updates to be as stable as possible. So we have a whole list of criteria that we use to decide whether or not a bug fix should be included in a release update. One of the criteria is, for instance, that the bug fix must be running in our main code line for a while to ensure that we catch side effects. Critical bugs like wrong result, hangs, or corruptions are very likely to get included in a release update. And also regression fixes, side effects that we introduced in a previous release update, is also very likely to be included in a release update. But in some cases, even though that we have a high priority bug, we cannot include them in a release update. This could be the case, for instance, if a bug fix is not standby first installable or not RAC Rolling installable. Now, we've promised you that release updates and revisions are always standby first and RAC Rolling installable. So if a bug fix doesn't meet this criteria, we won't include it in the release update. And it could also be that there are changes to the default behavior. Such changes will never make it into a release update. So once you have had your bug fix, we will deliver it to you via a patch. The most simple patch is a one-off patch, and it contains only one bug fix. Now, you could also get a merge patch, which contains 2 or more bug fixes. And this could be the case if your specific bug fix is dependent on another bug fix. Then we can ship those 2 in a merge patch. And then we have the bundle patches, which are collections of many bug fixes, and release updates and revisions, release update revisions are very good examples of bundle patches. Now let's have a look at what's actually in a patch. And roughly speaking, there can be two kinds of things: files and SQL or PL SQL. Files could be, for instance, new or changed executables. If there was an error in the SRV-CTL utility, we would ship out a new executable with a patch. It could also be libraries, or it could be the files that are used for time zone information. The files are changes to your actual Oracle home, to the files that are stored in the operating system. In addition to that, we have SQL or PL SQL changes. These are changes that happen inside the database. This could be, for instance, changes to data dictionary tables. It could be fixes in some of the Oracle maintained packages, like, for instance, DBMS Scheduler. Now, how do you apply a patch? Well, if you look in your Oracle home directory and go into the OPatch directory and do an ls, you would see something like this. And there are actually two files that are of interest: the OPatch and DataPatch executable. So let's have a closer look at what those two executables can do. Now with OPatch, you can apply binaries or changes to binaries in your Oracle home. So you'll use OPatch to change the files or add new files to your Oracle home. Now, since we are messing with the Oracle home, with the binaries that are running the database, when you use OPatch, it is a requirement that all instances are shut down. All the instances that are running out of that Oracle home has to be shut down. In contrast to that, you can use DataPatch to apply the SQL or PL SQL changes to the database. Now, since we have to make changes to the actual database, this requires that the database is up. And you only have to start the database in normal mode. And I know from time to time there is confusion whether you should start the database in upgrade mode or not. But to use DataPatch, you just need to start the database in normal mode. So let's move on with patching. Our very clear recommendation is that you do out-of-place patching. What does that mean? Well, imagine that you have your Oracle home. In this case, it's a 1990 Oracle home, and you have a database running in that Oracle home. What you should then do is that you should provision a new Oracle home, either install it from scratch or clone an existing Oracle home. You then use OPatch to apply the patch to the Oracle home. You can do that without any downtime because there are no databases running in that Oracle home. Once you've done that, you can shut down your database that runs in the original Oracle home, and you can restart the database in the new Oracle home. You'll notice that the color has changed to green, and that's because we're missing something. We've used OPatch, but we still need to use DataPatch to get the last changes in. So let's do that now. We call DataPatch, and please remember, always use the -reverse option of DataPatch because it gives you much more detailed information that you can use in a situation where you need to debug something. After that, the database turns to green. You can now start to use it. It has been fully patched. And when you try that use case that gave you an error before, now with your bug fix included, the database works perfect again. As you saw previously, there was downtime when we restarted the database in the new Oracle home. Now, if you have DataGuard, it is possible to patch your database without having to take the database down. How does that work? Well, you have to use what we call standby first patch apply. And imagine this scenario. We have a primary database and a standby database. Both of them are running on the original Oracle home, and we want to patch them. What do? First, we install a new Oracle home on both the primary and the standby host. Next, we use OPatch to apply the, in this case, 19.10 release update to both of the Oracle homes. Next, we stop the standby database and we move it to the new and patched Oracle home, and then we restart it. So now the primary database is running on the old binaries, and the standby database is running on the new binaries. But this is a fully supported situation. The next step is optional. you can convert the standby database to a snapshot standby database and then run data patch on the standby database. This will allow you to test your application on your standby database with the patch included. This is very, very useful, and I would recommend that you incorporate this into your procedures to ensure that everything works. When you're done with your testing and you have validated the new release update, you can simply revert the snapshot standby database back into a physical standby database. It'll use Flashback database to remove all the testing changes that you introduced and then catch up again with the primary database. Now we are ready to proceed with the patch apply. What we do now is that we issue a DataGuard switchover. So we send the users from the primary database to the standby database, and there's a role switch. We also reverse the flow of the redo. So now redo is being sent back to the original primary database. If you have a properly configured application, which for instance supports application continuity, there won't be any downtime at all, just a small brownout while the sessions are moved to the new database. When you've done that, you take the original primary database, which is now the standby database, and you restart that into the new Oracle Home. So now both of the databases are running on the new Oracle Home. But remember, we haven't run data patch yet. So we do that, we connect to the primary database and we execute data patch. And again, remember the verbose switch. Now the SQL changes and the PL SQL changes that go into database now flow via redo to the standby database, and now both of the database are patched. If you have DataGuard, I highly recommend that you look into this approach, and you should visit this MOS note to get a lot more details about the procedure. Also, there are some requirements and prerequisites that you have to meet in order to use this procedure, but visit the MOS note for further details. In addition to that, let me mention RAC Rolling Patch Apply. If you have a RAC environment, you can patch your entire cluster without any downtime at all. So imagine this. I have a 3-node RAC cluster, and the users are connected to all 3 instances. Now I want to prepare the patch apply. So what I do first is that I deploy new Oracle Homes to all of my nodes in the cluster. Again, no downtime. I haven't touched the database or any of the instances. Now I need to apply the patch to the Oracle Home. And again, I use opatch apply for that. And I do it on all of the Oracle Homes on all of the nodes. When I'm done with that, it's time to move the instances onto the new Oracle Home. And I use opatch auto for that. And it will take each node at a time. It'll drain the instance, stop it, restart the instance in the new Oracle Home. And users are then allowed to connect to the instance when it runs in the new Oracle Home. And it'll do it, as I said, node by node. So there's no downtime. And if you have a well-behaving application, it'll react to the events. Or if you have application continuity, it'll ensure that your application doesn't even know that your session is drained from one node and connected to another. When all the instances are running on the new Oracle Home binaries, it's time to finish the patching by using data patch to apply the SQL or PL SQL changes to the database. So as you can see, you can patch the database on RAC in a fully rolling manner, and with a well-behaving application, there is no downtime at all. Let me sum up by mentioning again that release updates and release update revisions are always standby first installable and RAC rolling installable. So if you have high availability architecture, there is really no excuse anymore for not applying patches. You can do it with a well-behaving application without any downtime. And finally, let me mention how you can get the details about your patch inventory. How can you get the state of your Oracle Home? Well, you can use opatch ls inventory. It'll give you a very detailed list about the software, the Oracle Home software you have installed, and all of the bug fixes, the release updates, the one-offs, and so forth that you have applied to it. This is very useful information, and you should always include the contents or the output of opatch ls inventory when you get in contact with my Oracle support. Also, let me mention DBMS Q opatch. which can supply some of the same information that you can get from OPatch LS Inventory, but you can get it while you're connected to the database. When you use OPatch, you have to be connected to the database host itself. And finally, if you need to know which SQL or PLSQL patches that have been installed in your database, you can use the view cdb_registry_SQL patch. It has detailed information also per PDB about which patches have been installed.
When patches get released, how you find them, and if you need to apply them or not. And let's start here with find the right patches. So it sounds odd to include that, but it's not trivial sometimes. And when you put in 19.10.0 Linux in the search window on Microsoft support, I guarantee you find everything except for 19.10.0, almost certain. So let's start here, and let's start with when do the patch bundles get released? So the patch bundles get released in a quarterly fashion in January, April, July, and October, always on the Tuesday closest to the middle of the month. And those of you who are experienced patching experts, you may know already that some of the patches may be delayed. Typically, the Windows bundle patches are a very common example, which is not available on that date, but usually a few days or sometimes, in worst case, also a few weeks later. In the patching notes, there's always a table inside telling you when patches are delayed and when the supposed to be available date is then. But quarterly, we release the patch updates, which means the bundle patches, always on the Tuesday closest to the middle of the month. So typically you see dates like 18th of January or 20th of April. That's typical dates. But now the question is, do you need to apply them? Do you have to apply them? And as a first evaluation, you can evaluate the risk. You can check how impacting are the security issues fixed in this patch bundle. And for that purpose, we deliver with each of the quarterly patch bundles a risk matrix. And the risk matrix is something a lot of our software vendors do as well. What you should pay attention is, first of all, the component column here, because the component tells you if a component you may use is affected. Or the other way around, if there's a security issue with a component you're not using, like for instance here, the third one from top, sharding, you may not use sharding, or if you don't use Oracle text, the second one from the bottom of the slide, then you don't have to care about that issue. But the first one here, the RDBMS scheduler, is in your RDBMS. So even though if you're not using the scheduler, somebody else may be able to use the scheduler, unless you completely disabled the use of a scheduler. And then the next information you need to pay attention is the base score. So this is in the middle of the slide. And the base score 8.8 is pretty high because the high score is 10. So nothing can be higher than 10.0. So 8.8 means this is relatively risky. It seems to be a big problem. And then when you go with your eyes to the right, you see how complex the attack is, if there are any special privileges required. Like the second one here, the advanced networking option, no privileges are required for that. But the attacking complex is relatively high. That means it's not trivial. You need a little bit of extra knowledge. You need to do this, that. Maybe certain things need to be settled before. All this should help you to get a better idea. But even if you call me and ask, hey, Mike, what is that issue about, that CVE 2021-2018? I can't tell you more than that, because it's a security issue, and these issues are only visible to a very limited number inside of Oracle, very limited number of people inside of Oracle. So neither Roy or Daniel or I typically can see the security bug fixes, and we don't know more than you about that. Then next thing, which is really important, on the right side of the slide, the supported versions affected. Because now you can get an idea if your version will be affected. When it says like here, the first one, 12.102, 12.201, 18 and 19, I can almost certainly guarantee you that this issue applies to 11.204 and to 11.203 and to 10.205 most likely as well. As long as the scheduler is available in the database, that issue happens. But here, we will mention only the versions which are under bug fixing support right now, and if those are still affected here. If it says like the second issue, only 18C and 19C, that means, okay, I'm on 12.201. I hope you don't, but if you are still on 12.201, you're not affected by that one here. And also see there's sometimes a note for the second issue. There's a note, something below the table. I didn't put that here on that slide. So use the risk matrix to evaluate how critical things are for you. And if something is in like this one here from the July 2019, so quite a while ago, core RDBMS, and I guess this had something to do with the password authentication. This was a 9.8. 9.8, that means, okay, you need that. Now keep in mind, the patch bundles are cumulative. So for sure, you don't have to go back and say, oh my God, I need to find July 2019 because there was this 9.8. Of course, you take the January 2021, and then everything from the previous ones is included as well. So no worries here. And then something which is really important to explain, and a typical, I would say, a topic for broader discussions. And sometimes when you discuss this with customers, also some energy is in the air, actually, the Java Virtual Machine, the OJVM. And there are a few things to clarify here. So do you have OJVM in your database? Do you need OJVM? And do you use OJVM? So these things need to be clarified. And why am I insisting here? This is the reason. So if you have the Oracle Java Virtual Machine in your database, I went back, I revisited all the security bulletins, the security matrices back to January 2015. And I used always the highest scored OJVM and put that in a slide here. So the average is almost 8 of the risk score. And you see there are some like below. Recently, they're only a 3.1 and a 4.8. But you see over time, there are a lot of 9-ish risk scores for OJVM. And in some of the bulletins, there were also 2 or 3 OJVM fixes included. So I took always just the highest here to scare you a bit. And this is not to say OJVM is bad. OJVM is extremely powerful. And if you have stored Java code in the database and you use OJVM, I've seen a lot of good presentations by external guys, some ACE directors, who showed clearly how much faster your Java code gets run when it's in OJVM. So OJVM is a good thing, actually, but OJVM is extremely powerful. And that means if something is so powerful inside the database, if there's a security loophole, that may be very, very critical right away because OJVM itself is so powerful. So don't get me wrong here. I'm not saying OJVM is bad. I'm just saying if you have OJVM, the probability that you have to patch quarterly is extremely high. And you can either use the OJVM bundle patch, which is a separate download, which I use, or you can use the combo patches. The combo patches have OJVM database and I think also the grid infrastructure. So it's a bigger piece with separate subdirectories, and then you can decide what you want to apply, whatever suits you better when you download. But anyways, how do you find out if OJVM is in your database? You query in a non-CDB DBA registry, and in the CDB, you query CDB registry, and then you check for the component Java VM. So if Java VM is there, that means you have OJVM in your database. And that means you have to take a decision now. The decision will be, first of all, you patch it quarterly. because you saw my scores, you saw the graph, there's always, almost always, certainly an issue with OJVM. So you have to patch quarterly. Separate downloads, or you use the combos. And that's a bit of a downside with OJVM patching. It requires downtime or a blackout of the Java subsystem. Now, the good thing is, if you have a RAC environment, since I think something around the 18.5, 18.6 patch bundle, OJVM can be applied rolling in a RAC environment, and you have only a blackout in the Java subsystem. And if that blackout hits you, it's only a matter of if you are using OJVM or if you are not using OJVM. Because if you have no application using OJVM in our database, then that blackout doesn't matter for you. It's a blackout to the Java subsystem, not to your entire database. The Java subsystem needs to be restarted. And if no Java application is using the OJVM in the database, who cares? So it's important that you can apply in a RAC environment the OJVM patch in a rolling fashion. If an application is really using the Java VM, then you have a blackout, then you better do this flip in a time which is off-peak. But this MOS note here, it's labeled with RAC rolling install process, which I personally think is not a great idea, because this MOS note has detailed queries. And this is why I put the screenshot up here. It has queries to help you checking if you are using, if somebody is using, if an application is using Java VM in your database. And this is often not trivial to find out. And this is why there are queries in here. And you see already these queries go on $X structures. So they help you to find out, is somebody using my JVM or not? And don't get this wrong. If you have a Java application running against the database, that doesn't mean that it's using OJVM. I would say only a fraction of Java applications use our OJVM in the database. So use that node regardless if you're RAC or non-RAC to find out, is OJVM used in my environment? As an alternative, you could disable OJVM. So first option, you patch it quarterly. Second option, you disable it. And you could disable it with the mitigation patch. The mitigation patch is in all your environments, I think since 2018, whenever you have a patch bundle applied, or could be even since 2017. Otherwise, for older, I don't hope that anybody is on an older patch level, but in case there's a one-off patch available, which brings the mitigation patch to your environment. You would use the mitigation patch in cases where you can't patch OJVM right now. So you know that there's a critical issue, but you have no option to patch at the moment, or when you can't remove OJVM. So you know it's not used by my applications, but I need to do something. The mitigation patch is not RAC rolling installable, but actually you won't care because it's in your environments anyways. You must disable the mitigation patch when you want to patch or when you want to upgrade your database. So when you use auto upgrade, we tell you, oh, wait a bit, there's the mitigation patch in place. You need to disable the mitigation patch because the mitigation patch, when it's on, it disables the Java subsystem. And when you want to patch or when you want to upgrade your database, the Java subsystem needs to be available. If it's there, otherwise we can't upgrade it. There's a good MOS note explaining, and when you go to the upgrade blog, you find a lot of blog posts. So just type in OJVM, like things to know, or do you need the mitigation patch in root and all PDBs? So I explained just a few weeks ago how to apply the mitigation patch correctly and provision it with new PDBs right out of the box. Now, how do you enable the mitigation patch? What does that mean? So you run a script, dbms jdef.sql, and that brings now in the functionality of the mitigation patch in your database. And the functionality is used in the second call. You disable the Java subsystem now. So you say dbms java def .disable. And when you disable the Java subsystem, the security issues don't affect you anymore. Because if the Java subsystem is disabled with that call, I can't do any harm by misusing OJVM security issues. So that's good. Only before you patch or before you upgrade, you must make sure that you enable the Java subsystem now again. Because otherwise, even for dependent patches, it could be that a component is depending on Java VM. And when that component applies a patch and the Java subsystem is disabled, that patch apply will fail. So you need to be sure before you patch, before you upgrade, that you enable the Java subsystem again. And afterwards, you disable the Java subsystem again. It's very important to disable the Java subsystem also in the PDB $seed to ensure when you provision fresh PDBs and you expect them to have also Java subsystem disabled. So you need to make sure that you apply the mitigation patch. If it's on there, it's also in the PDB $seed. Otherwise, what would happen is you have 5 PDBs, you have the mitigation patch, it's available, and you disable the Java subsystem, and now somebody's provisioning a new PDB, and the mitigation patch is active in there, but the Java subsystem is enabled. So instead of going into every new fresh PDB, you would make these adjustments to the PDB $seed, and then a newly provisioned PDB will have the Java subsystem out of the box disabled. You can enable it later on if you need to. Just be aware when you want to patch, you need to enable it. The third option would be remove OJVM from the database. So our OJVM colleagues don't like that recommendation, but in some cases, it's the only way. And honestly, as we may explain in one of the follow-up seminars about upgrade speed, the less options, the less components you have in your database, the faster your upgrades run. So if I take on just my upgrade classes, I would strictly recommend and say, hey, have only the options you really need in your database. And by not having the option, you don't care about the security potential of that option. You can safely remove OJVM. It's possible. It's explained in these 2 MOS notes. What you do in these 2 MOS notes is you simply, they're called save, repair, and reinstall. So fully politically correct here. But you just stop after removal, because both MOS notes describe how to remove OJVM completely. And then you stop at this point and you don't reinstall. And then OJVM is gone. You can also go to the upgrade blog. So the link below here, Java VM and XML cleanup in the database, gets you to the upgrade blog where I explain how to remove components from the database correctly, because sometimes it's not in the documentation or it's in different places. Some removal instructions are in MOS notes, like here. You won't find anything in the official Oracle documentation how to remove OJVM. So in that case, it's in the MOS note. These are the options, and decide what fits best in your environment. Now, another question which is coming up, I would say on a regular basis, is, do you need to patch grid infrastructure with OJVM? And my clear answer is no. No need for that. And we went in, I have a colleague in the RAC development, and we went in at Open World a while ago, and we sat together with our laptops and we tried it out. So there are 2 databases potentially in a grid infrastructure environment. One is ASM. ASM is a database. And the other one is Grid Infrastructure Management Repository. In both cases, there's no Java VM component. There's not even JOCs linked into the executable in GI. So there's absolutely no potential for misusing OJVM in these cases. And hence, I don't think that there's any reason to apply the OJVM patch to your grid infrastructure installation. And then another thing of discussion, I would say, is, does OJVM require a startup upgrade when you apply it? And also clearly, no. This is a leftover from the dark ages, I would say, in the README. And when you go into the README, it has still this table explaining how to start up upgrade and blah. And then below that table, you find fine print explaining, but when you have a RAC, and then it goes from fine print to fine print to fine print. And the bottom line is, yeah, you don't need a startup upgrade unless you have an application really using Java VM and you want to prevent or block a potential brownout or blackout on a Java subsystem. In a regular environment where I have no RAC and I can't apply the OJVM binaries rolling anyways, I just bring up my database and I do my data patch verbose, and all is good. I don't see any reason why you would need a startup upgrade. And we discussed this internally and we tried to convince the README owners to make this more clear, and it's not clear in my opinion. So take it like it is, but keep in mind there's no startup upgrade required. I don't know any rational reason why that should be the case. If you had done startup upgrade before to apply OJVM, then you need to use data patch minus verbose minus skip upgrade check. Because if you used on the same release only, if it was like you used that in 12.102 and now you're 19c, you don't care. But if it's still the same release and you used the startup upgrade before, then the patch will like have a sort of memory and tell you, no, I need a startup upgrade. Then you call data patch with this minus skip upgrade check and all will be good. So no need for that. And another thing we introduce, we apply also now, luckily, since April or since January 2020, we apply also a JDK update with the release updates. So an RU delivers also a JDK update. There are 2 or 3 things to mention here. First of all, the JDK team is only considering the JDK from the previous quarter as the last stable run. So you don't get the most recent one, you get only a 3-month-old one. Not our decision, and I know from some customers that if there was a known JDK issue and a lot of people use security check scripts, this will be sometimes flagged. So in that case, you may download the newest one and apply it. You get always current version -1. Second thing is, this is not happening on Windows. For whatever reason, I can't explain you. On Windows, the JDK, at least I checked in October the last time, it was not included. It was left out. So be aware of that. On Windows, you need to apply a separate JDK patch or take it from the Oracle.com website. Third thing I want to mention here is there's not only a JDK in the database home. There are several JDKs on the environment. So be aware also grid infrastructure, for whatever strange reason, has its own JDK. So there you must make sure that it gets patched as well. So be aware of that. For the database, it's included now. Please check also the other JDK installations in your environment. And regarding common patching cycles, JDK, you find a lot of information on the blog. So every time, every quarter, a new patch bundle round is coming up. I try to apply them as quickly as possible to see if there are any issues. If you need a new patch, go for a risk matrix. So you find on the blog quarterly blog posts patching all my environments with the patch bundles on a regular fashion. So feel free to tune in and get some recommendations. At the moment, no RAC is included here. It's a project if time allows. One thing I wanted to mention is that there's this MOS note about release update patch links. So it's called proactive patch information, which I think is very misleading. It gives you all the links to all available patch bundles for a release. So for 19c, you don't only find just the database patch 1910 and 19.9 and 19.8, but also grid infrastructure. Of course, also the revisions if you want them, but also JDK, OJVM. So all the available patches for a release are in these nodes. And you see on the slide also there's one for 18, 12.2.0, 1 and so on. So this is a good overview node actually, and for me it's also in my bookmarks, in my favorites on my Oracle support, because I use that on a regular basis. Okay, then it's time to go to the next topic.
Next, let's look at how you can download and install the patches. This is a high-level overview. First, you check OPatch, then you download and unzip your patch, you check for conflicts, you shut down the databases, listeners, and so forth that are using that home, and then you apply the binary changes to your Oracle home. I strongly recommend that you always use the latest version of OPatch. You can get it from my Oracle support node, and if you search for patch 6880880, it'll take you to a one-stop page where you can always find the latest version of OPatch for any given database release. And it's super simple to install a new version of OPatch, so there is really no excuse for why you shouldn't always update it before you apply a patch. So let's see how it works. Imagine that I've already been to my Oracle support and downloaded the latest version. It comes as a zip file. So now I log on to the database host and I navigate into my Oracle home folder. And I simply remove the OPatch directory, and then I copy in the zip file that I downloaded from my Oracle support, and I put it in my Oracle home directory. Now I can simply unzip it, and it'll contain a new OPatch directory with the new version of OPatch. After that, I can remove the zip file, and I can use the OPatch utility with the version argument to find out which version of OPatch that I'm using. When you have to download your patch, I recommend that you use the patch download assistant, and you can get it from this MOS node. Also, I really recommend that you click the little yellow star that is left to the heading and add it as a favorite, because you will return to this page from time to time, at least every quarter, when you have to download the new release updates. So let's see how it works. You can see here that I've already marked this document as a favorite. And now I want to find a release update for my database. I go into Oracle Database Updates, and I click on 19 because I have a 19c database. In the top of the list, there is the January RU, and I click on it. I then find the patch that matches my platform. And then I start to download it. It is quite big, which is kind of good because it leaves you time to get a cup of coffee or a cup of tea. While the download is in progress, you can open the README file to get information about the release update. Very important, if you go into the prerequisites, you can see which version of OPatch that is the minimum required version to apply this patch. There's also a link to the patch node where you can download a new version of OPatch. In addition to that, there are instructions on how you can perform a patch conflict check. And a little later, there's also the information on how you can apply the patch. And it's important here that you go into the patch directory and then run OPatch apply. You have to be in the patch directory, otherwise you will get an error from OPatch. So now the patch has downloaded. I'm finished with my coffee or my tea. Now it's time to check for conflicts. I create a directory where I put my zip file that I downloaded from my Oracle support. And then I simply unzip it. I change into the directory that holds the patch. It matches the number of the patch. And now I can use the OPatch command to check for conflicts. OPatch succeeded, there are no conflicts. I can now shut down the database and the listeners that run out of that Oracle home before I finally apply the patch using OPatch apply. I have to verify twice that my environment are ready to be patched, that there are nothing running out of that Oracle home. And after a little while, OPatch succeeds, and I've now applied the patches to my Oracle home. The next step is to apply changes to the database.
Once you've applied the binary changes to your Oracle home using OPatch, it's time to update the Oracle databases that use that home. And that means applying SQL changes to the database. The way to do this is to use the data patch utility. And data patch is the follow-on to SQL patch. And if I have to sum up its function in kind of one sentence, it makes your database match your Oracle home. So whether you've got more patches in the Oracle home or coordination needed between, say, the executables and the PL SQL packages in the database, or whether you've rolled back patches from the Oracle home, data patch will just do the right thing and make the database match the Oracle home. We've made a lot of improvements to data patch over the years, including things like increasing the number of pluggable databases that can be upgraded efficiently or patched efficiently in parallel. We also have added thresholds for the recompilation of invalid objects to give you control over whether UTLRP will run automatically as part of data patch. Because what can happen is once you replace a package body, for example, you may find things that depend on that have to be recompiled on the fly in order for your applications to use them. That'll all happen under the covers. That's just the way PL SQL works. But sometimes having that UTLRP run during the data patch period will just give you a better user experience overall, kind of more even performance for your applications. So let's demonstrate how data patch works when we're applying changes to the database. And remember, we will already have applied the OPatch changes to update the Oracle home. So first we have to start up the database and make sure in a multi-tenant environment that you start up all of your pluggable databases if they aren't set to be opened upon CDB startup. Then you simply go to the Oracle home OPatch directory. That's where data patch lives, the executable. You execute data patch, you can give it the verbose tag, it'll tell you everything it's going to do. No real arguments needed there because it will determine based on what's installed in your Oracle home and the patches installed in the Oracle database, whether anything needs to be rolled back or applied in order to make them match up. So it's pretty simple. And at this point now, what we've done, we've applied the 19.10 release update where we used to have 19.9 on that database. Now, when we're dealing with patching a container database, it's again important to know that data patch simply does the right thing, but it will only do that on the pluggable databases that are actually open. So with each pluggable database, by default, a pluggable database will not be open upon container startup. You can set that. You can set the startup state of a container for each PDB. But just to make sure, it's a good idea to do an alter pluggable database all open when you're going to be patching that database. We will take care of PDB seed, even though the seed database is normally read-only. Data patch has the intelligence in it to change it from being read-only, do the patching, and then close it back up so that any newly provisioned databases after that point will have the patches installed in them. Then you'll want to verify the result of your patching. Verifying the result, like many operations, is fairly simple. You would first check the log files for any errors or successes. Test appropriately. Now, testing appropriately, that's something we'll talk about. That the amount of testing that you need to do for most patches is relatively minimal. We do test our patches fairly thoroughly in Oracle, but of course, depending on the criticality of what you're doing, you should be testing to make sure that the patches apply properly. And if you are looking for a specific bug fix, test to make sure that the bug fix was effective in your environment. And then roll back or reapply if really needed. So here's a demonstration of rolling back a patch with, again, we'll do this with a combination of OPatch and data patch. So in this case, remember, we have this patch applied to our database, and that means that the first thing we need to do is roll it back from our executables, because we can't have the database running with more patches than are available in your Oracle home. So with OPatch, we roll back that patch ID, and it will go and change the binaries, and that binaries could be executables, it could be shared libraries, it could be wrapped PL SQL packages, any of that, and it will remove those from the Oracle home and put back the pre-patch versions of all of those images. So that could take a little bit of time, and now it's updating the inventory to note the fact that this patch is no longer installed in that Oracle home. Then we want to roll back the SQL changes from the database. And how do we do that? Good old data patch. Remember, all you do with data patch is you start up the database, make sure your pluggable databases are open, and then you just run data patch, and it does the right thing, because it can go into the registry of the database, determine which patches are installed within the database, compare that to your OPatch LS inventory, and determine which patches need to be rolled back. And there you go.
Now we would like to show you at the end of this presentation a special feature, patch when you install already. And this is something I personally like a lot, and I think we don't advertise this publicly visible enough. So the idea is that you prepare a directory, here in that case for grid infrastructure, and you unzip the download of GI 1930. It's always the base release. And then you unzip also the most recent, in this case it's 1990, release update. So it will be unzipped in a separate subdirectory. It will create a subdirectory for the patch, in that case 317.50108. And then when you call grid setup, you pass on this parameter -apply RU. And you mention the subdirectory's name here, which is the default name when you unzip the patch. So the installation will install grid infrastructure, but will, in the installation process, include also already the most recent RU. So instead of installing and then patching afterwards, you do this all in one pass. And the same, of course, works for the database. So same thing here. I create a directory for my database home. I unzip the base release 1930. I unzip also the most recent release update. And then I run the installer with -apply RU. And I pass on the subdirectory. Now here I created another subdirectory and unzipped the patch into a subdirectory. And there's a reason for that. Because you can't just apply an RU. You can also apply one-off patches at the same round. So you can tell the installer to apply the RU. And you see here also -apply one-offs. So for instance, in 1910, we have that issue with DBMS Optim bundle, where you can't enable the 1910 optimizer fixes. So you need a patch for that. And if you want to install this all in one pass, you can do that quite easily. The only thing really to mention here is you need to keep the patches separate in separate subdirectory trees, because if you have just one and you put all of them into the same subdirectory, the patch XML file gets overwritten by the next patch, and then the installer won't find it. So you really have to keep them completely separated from each other in separate trees to make sure this works well. Unfortunately, for those who will be on Windows, we have to tell you again that this feature hasn't been implemented on Windows yet. And something which is very important and which you shouldn't forget, to make this work, you need also OPatch. So before you start now the installation, you're so excited and you want to start it. Hey, wait a bit, wait a second. When you unzipped the base release, you unzipped your patches, you have kept everything in separate subdirectories, then remove the existing Oracle Home OPatch, so your future Oracle Home. You remove the OPatch directory, you copy the patch 688.0880 into this Oracle Home, you unzip it there, it recreates the OPatch subdirectory, and then it flows. So keep that in mind, and let me show you this with a quick demo here in one command. I like this quite a lot. So we create a directory here. I call it ROOH for rapid, for read-only Oracle Homes. I copy in my base release 19.3.0 into that directory, and I copy also, in that case it's 19.9, the Linux RU. And I copy also my OPatch I downloaded. What do I have? I have 19.3, 19.9, and OPatch. So I unzip first of all the base release. Then I clean up the zip file. Next is I remove the OPatch directory. And I unzip the OPatch patch bundle. It recreates that OPatch directory. Remove the zip file. And I do the same thing now for 19.9 in that case and remove the zip file. So everything removed here, set my Oracle home. And then I can call the installer. Run installer minus apply. In this case, it's only the RU, but the new OPatch is there. So it will prepare now the installation, apply the patch already successfully to the inventory at this point, then calls the graphical interface to the installer, set up the software. Here it's a single instance, Enterprise Edition, of course, Oracle base, permission set, please run my root sh. I pass in my password. It does the checks, Cluffy is running, and then the installation, which is basically a configuration of the unzipped directory happens. Linking happens. And now I still have to confirm that the credentials I passed on are okay. Database is successfully installed, patch is there. That's it. We could check now. Trust me, that works. I use this all the time. I think one of the coolest features since 18 actually, not in 19, it's not a 19c feature, and ready to be used. So a few tips for patching success. And this is our final topic here. So make sure you use out-of-place patching. In my homes, in the lab, I use in place because I have space constraints, but you should always prepare a new home. It helps you reducing the downtime. You just flip the database, you run data patch, that's it. And in case something goes wrong, you have your existing home still there. So always use a separate home for patching. Standardize your environments, use gold images where possible. As you saw, you can install and patch in one pass. That's super cool. Make your gold image out from that and then deploy it. Automate where possible, of course. Only way to survive these days, automation. Stay current on release updates. As we explained before, don't go live on something which is 6 months old. Run UTLRP before you invoke data patch. That's really a very helpful advice. And where applicable, use RAC Rolling Patching or standby first to further reduce the downtime.
Well, that's all we have for today's seminar, and thanks so much for attending to learn about Oracle's release strategy and best practices for patching. We hope this will be useful information as you approach your upgrade to database 19c.
And we will hang around in the chat for a little while to answer all your questions.
We hope to see you again soon. And until then, happy upgrading, happy patching. Thank you and goodbye.